This is Unit 2, Lesson 5, Linear Word Problems. Yes, we're doing word problems. I'm going to teach you the process of solving word problems so that we can have a set way of doing it every time. So, what we have to do when you solve a word problem, clearly define the quantities involved with common sense variable and let statements. So basically, whatever you're looking for, write a let statement. And then use your let statements to write out expressions and translate the information you told into an equation. So figure out your let statements for everything that you've got to find, and then write the equation based on the information. Then you solve the equation, and then check the reasonableness of your answer. Does your answer make sense? Sometimes when you solve it, you may get a weird answer and it doesn't make any sense, so you might have done something wrong. So let's take a look at some problems so that we can use this process to write the word problems, solve word problems. Okay, so let's start with an easy example. The sum of a number and 5 more than the number is 17. So what is the number? All right, now we could do some guess and check, but this is algebra class, so we're actually going to write an equation. All right, so the sum of a number and 5 more than the number is 17. So we're actually looking for two different numbers. We have the first number and we have the second number. All right, so we're looking for a number, which we don't know, so that's going to be our x. The other number is going to be 5 more than that number. So what does more than mean? More than means to add. So what would be 5 more than x? It would be x plus 5. All right, so now that we know what the numbers are, what do we do with them? All right, our key word here is sum. What does sum mean to do? It means to add. So that means we take the two numbers and add them together. So the first number plus the second number will equal 17, because is means equals 17. So the first number is x, the second number is x plus 5, and it equals 17. Oh, that looks like an equation we can solve. Combine your terms. 2x plus 5 equals 17. Subtract the 5. And you get 2x equals 12, and then divide by 2. And you get x equals 6. Okay, so we have the number is going to be 6. All right, now to check for reasonableness here, the second number would be 6 plus 5, which is 11. All right, they want to know what the number was, so it's 6. The other number is going to be 11. Do they add up to 17? Yep. 6 plus 11 does equal 17. So there we go. All right, let's take a look at the second number, or second problem. The difference between twice a number and a number that is 5 more than it is 3. Which of the following equations could be used to find the value of the number n? All right, so this time they're using n instead of x, so we got to keep that in mind. All right, now the difference means we do what? It means we subtract. All right, so difference means to subtract, so we're going to subtract something. All right, so the first thing we're going to subtract is twice a number. So if n is my number, twice a number would be 2n. Okay, and then we're going to subtract a number that is 5 more than it. So that's going to be 5 more than number would be the number plus 5. Okay, now since I'm subtracting, do I need parentheses here? Yes, I do, because I've got to subtract both the n and the 5. So to do that, I've got to make sure this is in parentheses. All right, so otherwise I'll just be subtracting the n. All right, and then that's going to equal, because it is means equals 3. So 2n minus parenthesis n plus 5 equals 3. And that is number 4. Okay, don't fall for number 1 because they forgot their parentheses here. All right, otherwise you're not subtracting the 5. All right, are we ready to go on? Okay, we didn't have to solve this. They just wanted to figure out the equation. All right, so the next kind of problem we're going to look at is an age problem. Evie and her father are comparing their ages. At the current time, Evie's father is 36 years older than her. 3 years from now, Evie's father will be 5 times her age at that point. How old is Evie now? Okay, that's really confusing. So we're not going to do guess and check again. We're going to see if we can figure this out. All right, now the trick to doing age problems is figuring out how old everybody is at different times. All right, so let's take a look at now. What do we know about now? Well, we have Evie and her father. All right, so at the current time, that's now, Evie's father is 36 years older than her. So Evie is the one we don't know, so she's going to be X. Her father is 36 years older than that, so that means he is going to be X plus 36. So that's how old Evie and her father are now. Okay, now we also need to know how old they are at a different point in time. 3 years from now is what we need to know. So I'm going to do another set of let statements here right next to it. All right, so we have to know how old they'll be in 3 years. Okay, let's think about this for a second. All right, so suppose you're 14 now. How old will you be in 3 years? You'll be 17, right? How did we go from 14 to 17? We added 3. So if we're going into the future, we would add the number of years that we need. So from wherever we started. So Evie is now X. How old will she be in 3 years? She'll be X plus 3. All right, now her father is X plus 36 right now. So he'll be X plus 36 plus 3 more years. So overall, how old will he be? He'll be X plus 39. Okay, so now we know how old they are now. We know how old they are in 3 years. So now that we know how old everybody is at different times, let's figure out what we have to do. Okay, it says 3 years from now, Evie's father. Well, how old is her father in 3 years? He's X plus 39. He will be. Will be is the future tense of is. So is means equals. All right, so her father in 3 years, X plus 39, will be equals 5 times Evie's age at that point. So 5 times Evie's age in 3 years. How old is Evie in 3 years? She's X plus 3. So if I want to do 5 times that, do I need parentheses? Yes, I do. So 5 times, X plus 3. So her father in 3 years will be 5 times Evie in 3 years. And there's our equation. All right, so let's solve our equation. Want to distribute here. All right, I want to solve this for x. I like positive x's, so I'm going to subtract the x. And I get 39 equals 4x plus 15. To get the x by itself, I'm going to minus the 15. And I get 4x is equal to 24. And then I want to divide by 4. And that gives me x is equal to 6. So whose age did I just find? I found Evie's age now. So that's what we needed to figure out. How old is her father now? They wanted to know how old they are. In case you want to figure it out, 36 plus 6 is 42. Okay, so he's 42. Now, if you want to check and make sure this is a reasonable answer, if she is 6 now, how old will she be in 3 years? She'll be 9. Her father is 42 now. How old will he be in 3 years? He'll be 45. So in 3 years, is he 5 times as old as she is? 9 times 5 is 45. Yeah, that's reasonable. So we just figured out Evie's age. She is 6. All right, let's move on to the last one. Kirk has $12 less than Jim. If Jim spends half his money and Kirk spends none, then Kirk will have $2 more than Jim. All right, so let's see if we can figure out how much they have. All right, so we have Kirk and we have Jim. It says Kirk has $12 less than Jim. Do we know how much Jim has? No, so he's going to be X, but Kirk is going to have $12 less than Jim. So whatever Jim has, we have to subtract $12 from, and that's going to be Kirk. Okay, now, if Jim spends half his money, all right, so after Jim spends, how much money will he have left? Well, he has X now. He spent half of it. So how much does he have left? He's still going to have half left. Okay. All right. So it says if Jim spends half his money and Kirk spends none, then Kirk will have $2 more than Jim. All right. It says Kirk, which is X plus 12 minus 12, will have, which means is in the future. So that means equals $2 more than Jim has after he spends. So 1/2 X and then plus 2. So Kirk will have what Jim has after he spends plus $2 more. Okay, so now we want to solve this for X. All right, so the first thing I want to do is get the X's on one side. Remember, there's a 1 really here. So this is minus 1/2 X. 1 minus 1/2 is still 1/2. And then I want to add the 12. 1/2 X is equal to 14. And then to solve for X, when I want to divide by 1/2, I want to multiply by 2 on both sides. So X is going to equal 28. Okay, so who has $28? It would be Jim. Jim has $28. All right, and then Kirk had $12 less than that, so it'd be 28 minus 12, which is $16. Okay, and if you want to check it for reasonableness, after Jim spends his money, he now has $14. So if he has $14 left and Kirk didn't spend any money, does Kirk still have $2 more than Jim? Yeah, he does. So that works. Okay, so that is linear word problems. So what we're looking for is write your let statements, set up your equation, solve the equation, answer the question, and check for reasonableness. All right, and that is the end of the video.